minute and we can start.
Okay.
So shall we start?
Yes.
Okay. Good evening, everyone. I am Madhu Asundi, Session Manager for this workshop. On behalf of RRSPBL 21 Organizing Committee, I would like to take the privilege of welcoming you all to the workshop on CDIO, Conceive, Design, Implement and Operate, an approach for engineering education development. I welcome all the participants and our eminent resource person, Kristina Edström. I would now like to give you all a brief highlights of today's workshop. The CDIO initiative is community of more than 160 institutions worldwide, collaborating on an approach to curriculum and course development in engineering education. The CDIO educational model is based on
Okay, so it's having, I think clearly text has been having some
similar to different from PBL. How can subject courses be taught in a way that also contributes to students' development of professional skills and many more? I would now take the honor in introducing you all to distinguished resource person of this workshop, Kristina Edström. Kristina Edström is Associate Professor in KTH Chalmers and PhD in Technology and Learning from KTH. Since 2018, she is the editor-in-chief of the European Journal of Engineering Education. She was awarded the KTH Prize for Outstanding Achievements in Education in 2004. And also elected lifetime honorary member of KTH Student Union in 2009. It is our pleasure to have you with us, ma'am. So with this introduction, we will move on to the workshop presentation. Over to you, ma'am.
Thank you very much. I will share my presentation with you. And does this look all right to you? You can see my slide, I hope. So,
not yet.
Not yet. She has to stop sharing her slide.
She has to stop. Okay.
Yeah, I'll just do that one. Yeah, now you can.
I'll try again.
Yeah. Now you can.
Perfect. Thank you.
Yeah, now it's coming. Perfect. Yeah.
Now you can see. Thank you so much.
Thank you.
So a little bit about where I come from. I'm actually in Stockholm, Sweden, which is north of Denmark, as you can see. So this is a country that has a long and dark winter, and then we have a short and wonderful summer. And I just had to boast that we actually have 29 centigrades today, which is very unusual. And nobody has an air conditioner because we put all our money in heating systems, otherwise we would die in the winter. And the short summer has just started. I just want to show you the first rose that opened in my garden. I cut it so that you could see it. It's the first rose.
Wow,
it always makes us very happy.
Very good.
So I'm standing here in a very hot room and I have the scent of this rose, and I'm very, very happy that I could address you and tell you about CDIO. My university, the KTH Royal Institute of Technology, I will just say KTH in the future. We are the oldest and biggest technical university in Sweden. In fact, when Edison invented the light bulb, KTH was already 50 years old. So it's a quite old place. I did not study there myself. I studied in Gothenburg, Chalmers. So, but I love it all the same. My background is actually that for the past 25 years, I have been working on developing our educational programs. And I have been working a lot on the international level, especially in the CDIO initiative that I'm going to discuss today. And I've been doing faculty development. So actually many hundred faculty members at KTH have taken courses that I have customized for them. My background is I have a Master of Science in Engineering, but I also have a PhD in Technology and Learning. And one of my finest credentials is that it was actually Professor Annette Kolmos who was my main advisor for that PhD. Well, basically you just need to know I'm an engineer. I like to fix things, and I will invite you to take a look at CDIO in the next 2 hours. Actually, I thought let's start with an example. I'll tell you everything later, but I just want to do 2 examples first. And my first example is, it's on the course level. I know some of you might say module. We have programs with courses in. I know that you would maybe say courses with modules in, but so when I say course, I mean module. I can't make myself say module, so I will say course, but I mean something that is half a semester long and students work on it about half their time, so they take 2 courses in parallel. So one of those courses is in basic materials science. So I suspect many of you have courses in basic materials science, and maybe even some of you teach them yourself. So you will notice that I know nothing about materials science because I actually took computer engineering and we didn't have that but my sister is a materials scientist. So this is Professor Maria Knutsson-Wedel from Chalmers, which is the other technical university in Sweden. She is also a CDIO person, and we know each other from the CDIO initiative for many years. She was actually, the year that I'm talking about now, she was Teacher of the Year because students liked her course. It was very clear what they had to do, and she was giving good lectures. She's very approachable. It's a very good course. Maybe you know materials and material science. She uses a book called Callister. It's a wonderful book. It's got color figures. But you know, when I went to Amazon to steal this picture, it said that the book weighs 1.6 kilos. So you could say that this course has 1.6 kilos of content. And the content, you know, you have to be able to interpret phase diagrams, and you look at the crystalline structures and you look for dislocations. It's very interesting. And Maria says it's almost not a joke that she could say something like this in the picture. I can't even pronounce half of the words, so I will not try. So her course was a standard lecture-based course with, you could say the focus was on the content, the disciplinary knowledge. Read Callister and write the exam with the same content and you will be fine. Now, we were traveling, Maria and I, to a CDIO meeting, and she and I, we like to go swimming. So we always book a hotel that has a pool. And I think actually we were swimming together, And Maria said, she said, you know, Kristina, there's something wrong with my course. And I said, what do you mean? You were teacher of the year, weren't you? Yes, she said, but there are actually two different ways you can see material science. And maybe we stopped swimming and started talking, because she explained to me that the course is really based on a perspective which is inside out. You start sort of inside the subject. So she says that material scientists, they love to have their eyes in a microscope looking into some kind of a piece from a machine that has broken, and they're saying things about the material and the performance of this material, why it broke, etc., what they need to do. But in a way, they are actually focusing on that nanoscale. So they are just vaguely aware about what is happening outside and what are the needs for this material. They are interested in those material structures themselves because they are beautiful and interesting and mysterious. That doesn't really work for the students. Maria said the students need to see the subject from the outside in. They can figure themselves as engineers who have a problem. And this thing on the screen here is, it's a hip replacement. It's a hip joint replacement. So you sort of operate it into your, it's disgusting to think about actually. But on this part is sort of put into the femur bone, and that means the bone matter should regrow as quickly as possible on this surface. That means that surface should have certain characteristics to allow the bone matter to stick to it. And it's very good because then patients get less pain. They don't have to spend as many days in hospital. And Sweden can sell bone implants that are twice as expensive as everyone else. So everyone is happy. And Maria says, actually, when you give the students a problem like this, like when they want to solve something that matters to them, they can see themselves as engineers working on this kind of problems. Actually, you are immediately on the left side, but now you're here with a mission. Now you are interested in those microstructures because this can help you solve the problem that you came in with. So Maria, she said that she needed the course to like remind students why they needed to know this. So always having the problem or the situation for a professional at the center. And now I know that you are in a PBL conference. So you all think that she turned her course into a PBL course, but actually she didn't. And I will show you what she did instead. And I will explain to you how that is part of CDIO. And we will discuss the strategy. But Maria, she wanted the course to be transformed from the view of knowledge that was from the inside out to the view of knowledge, which is much more from the outside in. So starting with the problem or situation. And in CDIO, we also use something called constructive alignment. And I assume that at least half of you have heard of it. It means that we use intended learning outcomes as the basis for course design. So we start by formulating the intended learning outcomes. What is it that the students should be able to do as a result of the course? And we consider, so what work is appropriate for the students to do so that they will reach precisely those learning outcomes? And that means we design learning activities because we want to generate this work that is appropriate for precisely these learning outcomes. And of course, we also design assessment. What evidence would we accept as evidence that the students have reached the learning outcomes? So what should they do to demonstrate to us that they actually really reach those learning outcomes? So Maria started. She started by changing the learning objectives. And you could say that previously, this course was very focused on the disciplinary knowledge in itself. You should be able to interpret phase diagrams, explaining hardening mechanisms, describe heat treatments. This was basically the chapters in the book almost. But she changed that. So instead of the disciplinary knowledge in itself, now it was, she calls it performances of understanding. Actually, she went to what an engineer can do with that understanding. So not just the understanding in itself, but also what you can do with it. So for instance, the second one, you should be able to explain how to optimize material-dependent processes, blah, blah, blah. Well, to do that, you need to do everything that was in the previous learning objectives. So basically, you can say that she wrote new learning objectives that were on a higher level. They still contain all the disciplinary knowledge, all the stuff in the course, all the 1.6 kilos of content. But now it's what an engineer can do with that understanding. So you have the knowledge, but you also have the ability to use it. So first she changed the learning objectives, and then, being a constructive alignment girl, she changed how the course works. So it's not PBL. Instead, she still lectures, and she still uses the same book with all the content, but she frames the content with problems or situations. So she always starts with some prompt to show how this knowledge that they are about to discuss, how it is actually used. And, you know, she has lots of friends and previous colleagues who are working in industry, and there is stuff that you can pick from the news, etc. So she's actually quite good at coming up with those, you could almost call it vignettes, that she uses in the lectures. Now, because the learning objectives are now more complex, if students should be able to do these things, they need to practice doing those things. So she has actually also added some learning activities to help students practice using, expressing and applying the knowledge. But she doesn't have 100 hours more to teach this course. So what she added was, most of it is actually self-studies or things that she could integrate into the lectures or stuff that they can do online, etc. But she felt that the students need to practice and to start making the knowledge their own. So she added those things for them. So what about the assessment? This is funny, actually. She told the students, we will have a new type of exam. And what I want to see is that you have a deep working understanding of these things. So I will ask much more open-ended questions, and it's possible that there are several right answers, but what I will assess is the quality of your reasoning. And also you should be able to put knowledge together from the different chapters and integrating and synthesizing that. What happened? Well, actually, the students did really well on the exam, but they freaked out in advance. They were so afraid. Actually, Maria, she showed me an email that she got. It was so cute. It said, "Dear professor, you said that you were going to give us an exam to test our understanding. We have never had an exam like that, and we have no idea what it would look like. Please advise." Maybe that student was actually right. So Maria felt that this was too stressful for the students. So the next time she actually added a formative midterm exam, a mock exam. So halfway through the course, they had an exam on half the book, if you want. And it was, Maria doesn't have 100 hours more, I told you, but therefore it's just formative. It doesn't affect the grade. She uses peer assessment. So students she uses a lecture. In the first hour, they write this test. In the second hour, they exchange papers randomly with each other and mark each other's. And in a discussion where Maria explains and they all discuss how to evaluate different answers. What if somebody answered like this? Should they lose all the points or just 1 point, etc.? Now, the reason she does it, of course, it's always good for students to read half the book halfway through the course, because it makes everything that happens from that point in time much more meaningful. But the main reason why she did this midterm exam is because she wanted to communicate to the students what was the kind of knowledge, the kind of understanding that she was going to look for in the final exam. So it was a way for her to show through some examples what kinds of questions she would be asking. So this example, I wanted to use it to show how we have been working in CDIO on making traditional, or previously rather traditional, subject courses much more meaningful to the students, but without going fully over to a PBL format. And I would like to invite you to discuss this in groups. Could you see any use for this strategy to have not just have the PBL format in your toolbox, but also having this other strategy in your toolbox? Could you see any reasons why you would want to do that? And we will divide you into breakout groups. And actually, we'll give you 15 minutes this time, because you will need a few minutes in the beginning to introduce yourselves. But I recommend don't use more than 60 seconds per person, because then you need to discuss the example and think about this question. Why could this strategy also be useful in addition to the PBL strategies that you have been discussing the whole day, I assume? And I have created a page on something called Mentimeter, where you can enter answers. And I suggest don't wait for the group to decide on a common answer. Anybody can answer any time that you like, actually. I will put the link. I will put the link in the chat so that you have it before we break out. So if you click that link, or I can also actually put up the, because for some of you it could be useful to do the Menti thing on another device, on a smartphone, for instance, so that you have two different devices. So I'll show you what it looks like. Okay, you'll get my emails for a second before I change the. This is what it looks like. So you can enter your answers there, and you can answer several times. So meanwhile, while you are discussing, I will read whatever you submit there, and I will respond to some selected questions that you might have. So please enter the breakout groups and see you back here in
Did you get pulled in the breakout room? I did not assign it for you. Oh, you're muted.
I'm going to a different computer where I can more easily read the input.
Yeah, sure.
Yeah. See you in 15 minutes.
Yeah. I visited few of the breakout rooms. I think there's no discussion that is happening. Okay, rooms are closed.
Okay, I hope we didn't interrupt you.
You're back.
I know
Yeah.
with experience that you probably had very lively discussions, and if we had been in a large conference hall, we would have known how wonderful discussions you had. Okay, so I have actually picked some of your input. Let's see if this works for me now. Yes. So I think you found, here is actually some of your early input. I think that you found a lot of very interesting aspects of this example. First of all, you noted that the strategy uses an inductive approach. So if you think about the two ways to see material science, the traditional one or the one that the materials professors preferred is the deductive, or you start with the details, whereas coming from the problem, the need to understand the engineering problem is a much more inductive approach. And of course, PBL is the major inductive approach to teaching. But here, it's actually also something of an inductive view on knowledge that is guiding the concept. And you note how it's more interesting and engaging for the students. And some of you note, after I made this slide, I saw some new inputs where you said, this could be a good soft start for the students. Instead of going straight into PBL and expecting them to do a lot of things, this could be a way that they are recognizing it more easily. In the right-hand column, I put so many answers that had to do with the feasibility of change. The biggest worry that all faculty members seem to have when we discuss PBL is, but what about the content? So this is actually a way to make the teachers who are...
Kristina, we are not able to see this screen.
Slides.
Yes, slides.
You're sharing something?
Yes, I'm sharing.
No,
Okay.
you're not. You're not
No.
sharing it.
Keith, you have to help her. For some reason, the slide is not showing.
Oh, sorry.
No, she has not started sharing.
Oh, she hasn't started sharing. Okay,
Yeah,
there
now
we go.
it's
Now we got it. Okay, there we go. Okay, but we could understand.
I'm talking about your wonderful answers, but here I can show them to you as well.
Yeah.
So on the right-hand column that I just came to, keeping the technical knowledge intact. I think there is such a huge resistance within universities to PBL because people are so worried about their content. So this is actually a model that a lot of teachers who are very focused on the discipline, they can accept this one because they realize that this is actually an improvement to just cramming and students just repeating whatever they read in the book in the exam. So they will be able to like this. And as you noted, there is not much investment. At least you don't need new buildings. You don't need a whole different setup. You can do some of these changes on a small scale. You can start with a single course, and you can and you can trust me that the students will tell other teachers, please, could you lecture a little bit more like Maria? And it's more acceptable to the basic setup that the most traditional universities have. So this might be an easy thing to start with. So thank you very much for the input. I will actually save all the input for later and read all of it. This was just what came in the first 5 minutes, so I could make the slide. So CDIO is an approach for engineering education development, where we actually focus as much on subject courses as we do on project courses. And you can say that we take a balanced approach, saying that we understand the role of the disciplines in the education, but we want them to give the best contribution to the programs that they can. And we also understand the need to have problem or project-led learning. So we need some courses to actually be designed in that logic. And here are some of the arguments we can use. The reason why we are accepting the role of discipline courses or subject courses is because we actually think it's quite good for the students to get a well-structured knowledge base. There is a worry that if students only would meet the disciplinary content in projects, that it could be too fragmented learning. Now, I know that there is, actually, I don't know of a single university that has only PBL. I mean, even Aalborg University has 50% of subject courses. So this is not in any way an argument against PBL, but what teachers or administrators in traditional universities think is that PBL is all PBL, and there is no room for subject courses. So in CDIO, we are very careful about our rhetoric, and we don't want to be misunderstood. We do see that subject courses have a place, however, they need to be really good. So we want to work with the disciplinary faculty, helping them deliver to the education what is their best contribution. Of course, we need problem-based or project-based learning. That's obvious. If our students are going to turn into engineers, they cannot just study the subjects. So in the project courses, they get the opportunity to integrate and apply knowledge. They get the opportunity to work on open-ended problems where it was not decided in advance exactly what theory they should use. Sorry about the noise. So they can also work on problems that are incompletely stated or where there is lots of room for interpretation, like in real life. But I tell you, disciplines hate open-ended problems, or because there the starting point is some content that the teacher wants to teach. So as it becomes more open-ended, more problem project or practice-led, there is no guarantee that students will learn exactly those equations, but they will learn whatever is needed to solve the problem. Another thing with the problems and projects is, of course, that you can work on real problems and you can work on problems that sit in a context. And disciplines hate context. They want to be generalized and abstract so that they apply like everywhere they think. But as an engineer, you need to work in contexts. You need to interpret contexts. So you have to get used to that also in the education. And there is the design element. Oops, the host has stopped my sharing. Please allow me to share again. Can you see my screen now?
It is
Yes,
fine.
we are able to see your screen. Please continue.
Yes.
So there is the design element that as engineers, we have to create solutions, and they cannot just be, it's not just applied science. There is a creative or design component to it. And I love this quote by Theodor von Karman, who says, "Scientists discover the world as it is. Engineers create that which has never been." So it's this creative thing. And students need also to get into the habits and understand the professional work processes of engineering, like teamwork, etc. Now, you can see in the icon, I put some hands there, because we want to really create a good relationship between the disciplinary courses and the projects. So whatever mode you are in, if you're teaching a disciplinary course, you should help the students develop a deep working understanding. That means an ability to apply the knowledge. Otherwise, it's not so useful, we think. And you could say that Maria Knutsson-Wedel's course was an example of seeing the knowledge through the lens of problems. Another way to make discipline subject courses more engaging is, of course, to integrate skills. It doesn't have to be projects. You can also integrate lots of skills and active learning approaches into subject courses. So communication, collaboration, all those things have a place there. Finally, if you are in a project, it's actually quite important that it doesn't turn into, you know, just carpentry because you are doing something hands-on. You have to let students discover how their theoretical knowledge is actually useful. So they don't see this as two different worlds. And if you create the motivational context, students will then be more receptive towards theoretical studying later. So you could say this is the hybrid view of knowledge in CDIO. We want to embrace both the logic of the disciplines and the logic of the problems and projects. And a little bit of a comparison then between PBL and CDIO, that PBL is much older. It started in the 60s and the 70s, but CDIO was created from the year 2000. So we are very much a child of our times. Like CDIO is an outcomes-based approach because that was the thing in 2000. But in PBL, it's more a focus on the process, how students should learn in a more democratic manner, you could say. There is a little bit of a hippie origin in PBL, and I just love that, especially in Denmark, perhaps. And CDIO, the starting point was more in the desired learning outcomes. What do engineers do? What kind of work do we need to prepare the students for? And that made us, and then as a consequence, students need to learn in a different way. But the starting point was, what kind of engineering graduate do we want to create? Oops. You can say that another difference is that PBL is universal. You can do it on one course or a whole curriculum or a whole campus, etc. But CDIO is much more focused on the program level, and PBL is seen as a component, a pedagogy for some of the courses. So PBL is definitely a component of CDIO, but it's not the only component. We also recognize the room for the disciplinary courses, and we focus a lot on the program level development, which I'm going to show you in a minute. So the level of disruption is a little different, whereas the prejudice against PBL is that it's challenging the disciplinary structure, and a lot of faculty members are afraid or they show all kinds of resistance to it. In CDIO, we try to shape the message and the methods in ways that can be acceptable for more of our faculty. I'm not saying that everyone likes it, but at least a majority of the teachers can accept it, and enough teachers can really engage in it so that we can make super good programs. I put a reference in the bottom to a paper written by Annette Kolmos and me, comparing PBL and CDIO, if you want more. Now, the PBL component in CDIO, we have a form of project course that we call Design Implement Experiences, where students actually design and implement products or processes or systems or services, whatever. And they aim, of course, to be near authentic so that students practice doing engineering. CDIO is defined by 12 standards, so this is standard 5, that you have at least 2 such courses where students develop technology. And through the curriculum, we think that you can have progression in several dimensions. But I'm going to talk about 2 things. Because we have been working on 2 frontiers here, and this work has been to a large extent done at my university in some of the courses there. So the focus is how can we improve learning in those courses, and how can we teach those courses sustainably without killing the teachers. So the learning perspective, we really figured out that the purpose is not to build things, but to learn from building things. We could see that a lot of teachers doing project courses around the world, they were actually talking about it as if the purpose is that the students should build stuff. But you could say that the learning perspective or they could not have a very insightful discussion about the learning, the design of the course from a learning perspective. So we have been working hard on that in CDIO. Just one detail, which is it's so obvious to me that the assessment, the grading, should reflect the quality of learning, but a lot of people assess and grade the product in itself. People can say things like, if your car goes 15 meters, you get that grade. If it goes 20 meters, you get that grade. And that's not a good idea. I think assessment and grading should aim for measuring the intended learning outcomes. And this product focus can be very much a trade-off to the learning. We also think, and I will elaborate on this a little because I think this has to be important for you as well, because a lot of people think that project-based learning must be very expensive and require so much effort from the teachers. But in the 15, 20 years that I've been helping faculty develop their courses, I think we actually have proof of concept that that's not necessarily true. And I'll give you some of my favorite principles that we have used. I'm thinking now of a specific course, but I won't go into it. But these teachers in this specific course, they have the project drive specifications, plans, deadlines, etc. So it's not the teachers who set them. If the student comes and asks them, when do you want the propeller report? The teacher says, oh, the propeller report is not for me, it's for the project. When does the project need the propeller report? Ah, say the students. Of course, we need to order the propeller on October 25, so probably October 15 then, so we can make the decision. And yeah, okay, I understand. And that means, first of all, that the teacher will not answer 5 million questions, but the students will be made to think for themselves. And it also means that things become meaningful to them. If they ask, how long does the propeller report have to be? Well, what kind of function does the propeller report have? Oh yeah, we're going to decide which propeller to buy. So we need to show that we have looked at the alternatives and, oh, I see, yeah. You know, when they write a report to show the teacher how much work they've done, they put in 14 unnecessary plots just to show that they've done a huge effort and want a high grade. But now they realize writing a report that actually has a function. Oh, that makes sense. That's easier, actually. It's the first thing, I can tell you, it's the first time that students do anything in a course that actually has a function. Otherwise, it's always been to show the teacher that you've done a lot of work. The students own the project, not the teachers. So teachers will not hand any solutions to the students or tell them what to do. They will advise them, they will coach them, they will help them in many ways. Especially they will help them in finding the right processes for the work. But it's not the teachers who are the project leaders or the technical input. So this means that students are not protected from making mistakes, and the final product will reflect the students' level of proficiency, not the teachers. So this is also a way to force the students to grow into engineers. Then we have worked a lot with the assessment, because often it's the assessment that is unsustainable for the teachers. So we work a lot with peer feedback, and I'll tell you about one more thing. But the feedback is very important, because learning by doing that's just bullshit. There is no learning from doing. You have to reflect on your experience if you want to turn it into learning. So therefore, we use reflection exercises and especially feedback to stimulate reflection, so that students will learn from their experiences. But it's not the teacher who gives all the feedback, but we use a lot of peer feedback and clever solutions. And the second assessment principle is to reverse the burden of proof. Students will collect evidence for that they have fulfilled the learning outcomes. If we have 10 learning outcomes, they will provide evidence of all those. And that will help the students direct their attention to what they are supposed to learn, and not just build a boat, but actually learn how to, and then the learning objectives. So, okay, this is a whole different workshop. Are you still there? Yeah, I can see you're still there.
Yeah, we are here. We're all here.
So I will give you now a second example. And we will do the same as previous time. You will have the opportunity to discuss this with each other. And now it's on the program level, the curriculum level. So you can imagine that Maria Knutsson-Wedel's course is actually one of the courses in this program. But the challenge here is that I'm going to discuss is how they integrated computational mathematics into a mechanical engineering program. And now it might be different in your universities, but at least in Swedish engineering education, we have felt for a long time that the mathematics courses did not keep up with the development. The mathematics courses actually looked very similar to the mathematics that we had in the 1980s. But if you look at how engineers use mathematics, they are using modern computer tools, and they are computing a lot of things that we couldn't do in the 80s, but actually the math courses looks the same. So at Chalmers, they wanted to reform the mathematics education in the mechanical engineering program. And I should say it's a 5-year program, so it's actually an integrated bachelor plus master. So it's 3 years bachelor and 5 years master, but you apply to the full 5 years. So before they can become good engineers, they will have the first basic math courses and then mathematics in different stages through the curriculum. And I'll tell you a little bit about it. But when I do, you have to think a little bit broader. So I told you that Maria's course went from a focus on the content or the subject matter in itself to the competence, what an engineer can do with that understanding. So that means that we now also have to emphasize the skills, the approaches, the judgment, the values, much more than just the content. So we need some mechanism to weave those things through the curriculum too. So we can't just have courses that take care of their scientific area, but all the courses also have to contribute to the skills and approaches and judgment. So actually the computational mathematics, you could think of that as a generic skill going through the program. It's not just associated with one course, it's associated with educating an engineer that comes out and has these tools by their fingertips, and they are able to do what the engineers do in industry. So it has to happen throughout the whole curriculum. And we have been working a lot about in making it clear how each course, each subject also contributes to those course program level goals, and that we have a progression through the curriculum. There are so many things in the curriculum that a single course cannot bear. So we have to think about how to do it throughout the courses. And then a lot of teachers, at least in the beginning, they were wondering, but why should I integrate skills into my technical course? For instance, one teacher said, I can't take away any lectures about thermodynamics to lecture about communication skills. And we said, well, no. You're not supposed to lecture about communication skills. It's through the way you teach thermodynamics, it's through the way that you assess thermodynamics that students also develop the communication skills. So you have to integrate it in a more orthogonal sense. And thereby we are using the time in two ways, because you are developing the skills, but simultaneously you are deepening your understanding of the subject because you are expressing it, you are applying it. So if you practice oral presentation, for instance, or oral communication skills, you are also practicing the subject because you have to communicate something. So that's how we use the time two ways at the same time. So I will show you now to the computational mathematics case. Now, it's not a coincidence that I have a car there, because Chalmers is quite close to the Swedish automotive industry. So this finite element modeling sketch is actually quite, it symbolizes to me what level of engineers we need to graduate, because that's what they're going to do when they get their first job. So in the mechanical engineering program, they wanted to modernize the mathematics content. And they also wanted to make much better connection between the engineering and the mathematics. Because for the students, it felt like the mathematics courses was one world and the technical courses was another world. So they really wanted that to be much better connected. And the analysis among the faculty was that actually students need to work more on real world problems and much less time on textbook problems, or as they said, oversimplified problems that can be expressed analytically and with solutions that are already known in advance. So less of the mathematics where you have a pen and paper and there is the right answer in the back of the book, right? That's not what they felt that was not so productive. And they wanted the students to be able to work on complete problems, as they call it. So modeling, simulation, visualization, and all the time keeping the physical reality in so that they can see that it's not too far removed from the physical reality, or they can interpret things in the physical sense as well. So how did they go about this? Well, here are some of the strategies that they used to infuse the program I wrote. So integrating this across the whole curriculum. The math courses, they had to develop new basic math courses. They didn't throw out everything old, but they integrated some elements that were making the foundation for the computational mathematics. So they had an introduction to a programming environment, in this case MATLAB, and students learned to use that and actually side by side with pen and paper, so that they could feel what kind of how this works. And the math teachers had to produce quite a lot of new teaching materials, because they discovered that there were hardly any textbooks that had any computational mathematics in them. So actually the existing textbooks were one of the most conservative factors it was difficult to do those new things because you couldn't buy any books to support you in your course. Those two are maybe the obvious ones, but then they also integrated some relevant mathematics topics into the fundamental engineering courses. So for instance, control theory. There were some differential equation stuff that they didn't do in the basic mathematics course because the experience of the faculty was that by the time the students came to the control theory, they had forgotten that, or they couldn't recognize that these were connected somehow. So instead, the control theory course teaches actually some of the mathematics topics because there it is relevant. There it is meaningful for the students. Whereas in the first year, it was something to be learned for later, but later they will have forgotten it. So some of the mathematics topics, they integrated into the technical courses instead. And they also created some cross-cutting elements between the courses. So for instance, mechanics and strength of materials courses had shared projects with mathematics courses. So I'd like to point to the very important human side of this, because so I don't know about your universities, but in many of the universities where I have been, there is a little bit of a conflict or tension between the mathematics teachers and the engineering teachers, where the engineering teachers are actually pointing finger at the mathematics teachers saying, you have to connect better to the technical stuff. But here they worked together. The mathematics teachers and the engineering teachers worked together. And it was just as important to make the connection to mathematics in the engineering subjects as it was to make the connections to engineering and mathematics. And because they worked together, they could make those connections meaningful. Because working together, it's much easier to make relevant and meaningful connections. So I think this was a very, very interesting case, and you can read about it in the paper. So as a bonus, I will also show you, because you can say that when you have this program-driven approach, when you have the ability to collaborate across the curriculum, collaborate between faculty and do things together, then you can do so much more than if you're just looking at your own course. So a couple of years later, the same program said, okay, we will need to do a much better job in integrating sustainable development. And here are the two first years in this 5-year program. So it's just we have zoomed in on the two first years. And they said, let us integrate sustainable development wherever that is relevant. So instead of putting in a separate course on sustainability, they decided that each subject has to consider where is it relevant to bring up aspects that have to do with sustainable development. And I'll show you how many places it was meaningful. And it's actually very interesting because in the beginning, some of the teachers could not understand how they could integrate sustainable development. So for instance, there was a math teacher, not at Chalmers, now this is at another university. There was a math teacher who said, well, I just teach mathematics. I don't see how sustainable development has to do anything with that. So I cannot do it in my course. But one of his colleagues said, but actually you do teach optimization. Wouldn't you say that most sustainable development problems are actually optimization problems? That optimization is a really important and useful tool for addressing matters of sustainable development. And he just said, aha, I didn't think about, well, actually, you're quite right. Yes, okay, I can do it, he said. So it was a little bit of work to look for those where it was relevant. And after beginning to see such cases, it was more easier to find the relevant contexts in many other courses as well. So you could say that the curriculum system that CDIO is based on, we look a lot on the connection between the courses and the programs. That the courses really have a function in the program, not just its own scientific content, but also its contribution to the skills, approaches, judgment, the maturity of the students. And we also look at the connection inside the course, that we make sure that we teach and assess what is in the learning objectives. So basically you could say, well, of course we have on the national level, we have some, in Sweden we have national learning outcomes for each degree. In many other countries you have accreditation schemes, etc. So those are a given. And then you have a vision for what your graduates should be able to do, a competence, which then contains both knowledge, skills, approaches, judgment, etc. And you formulate your program learning objectives. And then you apportion them to the course level so that all the courses taken together should satisfy the program learning objectives. And of course, it's a lot of courses. So I think the important connections are here. Are we sure that our courses are making the appropriate contribution to the program? And that is defined by its learning objectives and how it's aligned with the program learning objectives. And making sure that any program learning objective is represented sufficiently in the course learning objectives so that it's satisfied. But then, of course, also that we really assess that which is stated in the course learning objectives. Otherwise, it doesn't work on the where the rubber meets the road, if you want. That's assessment. Right, so I will run to another computer to change the input slide on the Menti scheme. And the new question is now, what kinds of improvements or what kind of problem solving can we do if we have this program-driven approach? And this time, because you don't have to introduce yourselves, you just get 10 minutes to discuss it. And everyone can enter your thoughts on the Menti webpage again. So I'll run and switch the Menti, or maybe I can do it here. No, I'll run to a different computer and switch the Menti. So join the groups and see you in 10 minutes.
10 minutes are up, I will end the rooms, close the rooms. Yeah.
Perfect. Thank you.
Yeah, they all are coming back.
You are coming back. Perfect.
Yeah.
Sorry for interrupting your discussions again. I can just assume that it was very lively because I saw your input. So as usual, I have discovered that I've been talking too long. So I will give you one example myself of the power of having the program-driven approach. And actually, I was just a month ago, I was asked to have a discussion with the faculty at another Swedish university. And they had problems in the thesis project. So and this was also an integrated 5-year program. So after 5 years in the program, they discovered that a substantial minority of the students did not write well enough to do the thesis project. And they added seminars and workshops and clinics and all kinds of help functions to support the students in developing their writing skills. But they felt that it was too tough. So they asked me to come to advise in this situation. And I asked them, can I see the program in the previous years? You're doing a fantastic job in the thesis project organization, but can I see the program that the students have been doing beforehand? And it turned out that they had written things in many previous courses, but they always wrote it in a group. So they actually had one individual writing task, but it was not very big. It was like 1 page, I think. All the substantial reports were written in groups. And I told them that this doesn't help the students discover whether they can write or not. And it doesn't help the teachers discover the students who really need to work on this. So instead of talking about adding more seminars to the thesis project phase, we discussed what to do in year 1, what to do in year 2, what to do in year 3, year 4, so that they can actually prepare the students so that they are competent for doing the thesis project. That's one of the powers with having a program-driven approach, because if you can work with the program as a whole, then you actually have a capacity to solve, I would say, most of the problems that that can be in education. So I hope you excuse me for rushing a little bit, because I wanted to get to explaining CDIO, because we saw 2 examples. We saw one on the course level or module and one on the program level. But what is CDIO? Why did I think that these were representative of CDIO? Well, CDIO is actually 3 things. It's a community of universities who work together to develop the CDIO concept and also share all the experiences. And we call it the CDIO initiative. And it's an idea, the community is based on the idea that we should educate engineers who can actually engineer. So to prepare them for professional practice by addressing the full competence that they need to be good engineers. And it's a methodology for curriculum development with the 12 CDIO standards. I already showed you standard 5, which was the PBL component. So about the CDIO initiative, it was started in the year 2000, and there were 4 partners. It was MIT in the United States, And it was 3 Swedish universities, KTH, Chalmers, and one in Linköping. And we had actually been working only for a short time when all our friends said, "You seem to have so much fun, can we join you?" And today we are over 180 CDIO collaborators or institutions who have officially joined CDIO. And this list actually doesn't cover all of them because I gave up on updating the list. We still have new universities joining, and I couldn't keep up with editing this. So you have to go to cdio.org to see the current list of members. But I wanted still to show you the list because it's so exciting to have friends in so many places. Because when we develop education in our own institutions, we also take a look at what our friends do in the other universities. And I tell you, you don't want to come to a CDIO conference without having something really good to report. So it's both friendship and collaboration and a little bit of competition as well. And actually, it's very interesting because when we try to change the education, we really understand how things work. So we learn a lot, even if the change is not always successful, at least is educational for ourselves. So we have a lot to share in the CDIO community. In fact, our annual conference starts on Monday. So, and it's online. We should have been in Bangkok, Thailand, but we will be online. Next year in June 2022, we hope to meet in person again in Reykjavik, Iceland, which will be lovely to see all the people again. But I'm looking forward to online as well on Monday, Tuesday, Wednesday. So yes, the idea is the idea is that we should educate engineers who can actually engineer. And we have taken, you could say we have taken a dual challenge because we see engineering education as having two sides. It is academic. It has theory in a range of disciplines, and it is professional because it prepares students for engineering practice. It's actually the same for all professional education. It's both academic and professional, and there are some tensions between those. And we think it's very important not to talk so much about either or how much of this and how much of that, but especially to work on the meaningful relationship between those two components of the education. And in CDIO, we think of it as having a dual challenge. We want the students to have a deeper working knowledge of the technical fundamentals, and we want them to develop the professional competencies. And we don't want to end up in a trench war or zero-sum game and say how much of this, how much of that. We want them to be integrated and having a good relationship. So I'll skip a little bit in the interest of time. And I'll introduce you to some of the CDIO standards. But in doing so, I just want to recognize that it's not a cookbook recipe. It's not like you add 2 grams of sulfur and it will explode the same for everyone. You always have to think about how can we implement this at our university, given the conditions that we have and our own preferences, etc. So you always have to translate and transform it to your own context. And also, I would say, there is no, CDIO is completely open source. So nobody is telling you to do anything. You can change all the things that you see. You can just take the things that you like, you can transform them, you can give them a new name and publish them as your own if you want, no problem at all. So it's completely open source. These are just ideas for anyone who feels a need for them. So here are the 12 CDIO standards. I have to apologize. They looked like they were written by an evaluation agency or something. So bear with me, they look very boring, but they are not. They are actually really interesting strategies for developing good education. Standard 2, standard 1 is basically recognize that our aim is to educate engineers who can engineer. Standard 2 then is formulate the learning outcomes for the program. And you have to recognize the dual nature. So you have learning outcomes both for the technical disciplinary fundamentals and for the professional engineering skills, so that you're sure that you have the full competence of the engineer that you. And you should also have a dialogue with stakeholders. So consider what is attractive to the students, what do the employers need, what does your society require, etc. So formulate the learning outcomes for the program in a dialogue with the stakeholders, and make sure to both address the technical disciplinary content and the skills for life and for working life. I will give you can download documentation later. We also have a document called the CDIO syllabus. It's basically a long list of learning outcomes or topics that you could take as inspiration for formulating your own program. So there is nothing prescriptive. No CDIO program has to address all of this, but it's an instrument that you can use for selecting the topics that you will emphasize in your program. And that depends on your local context and your own stakeholders. We're just updating this to version 3.0. In the end of the year, we will publish the version 3, which addresses sustainable development a little more and digitalization a little bit more. And it also takes into account some of the work that we have published in CDIO. So the strategy is to integrate. Students should learn the knowledge and the skills simultaneously because they belong together. So you could say that we want to integrate them because they give each other meaning. So instead of first having a few years where students just are force-fed with subjects, and then a little bit in the end of the education where they have projects, we think of integrating those two in all along the curriculum, so throughout the curriculum. And therefore we have emphasized having project-based learning and engineering experience early in the program, for instance. And standard 3, I would say, is the most important one in CDIO, the integrated curriculum. So you have a curriculum where you plan how to integrate all the skills and abilities and the professional skills throughout the program. Just like the graph that we saw with the Chalmers program and how sustainable development was represented throughout a large number of courses. So the integration and progression through education are important concepts in CDIO. This is actually a graph I made in 2003, I think. So we started by weaving skills through various courses and making sure that, for instance, if students had to write technical reports in 7 different courses, you made sure that the teachers knew what was made in previous courses so that they could take a step further and not just having, starting from square 0 every time. It's in the beginning, it was a little bit difficult for some of the faculty members to see why should I integrate skills into my course? And I remember one of the earliest discussions, we had a teacher in lightweight design and finite element modeling, Stefan. Stefan said, well, I would be happy to teach communication skills in the lightweight course because for me, it's all relevant. It's about using the technical concepts comfortably. And he said, for instance, when I give them an assignment, I want them to sit together and develop their ideas through discussion and collaborative sketching. And I remember asking him, what do you mean, Stefan, with that collaborative sketching? And he said, well, you know, they have a problem, they have a paper or whiteboard, and they start sketching how they think, and they discuss, and they erase and change a little bit, and they see it from different perspectives, and then they are a little bit, becomes a bit of an argument. So they start to have, no, I think it's because blah, blah, blah. And they do a little MATLAB thing, and they say, no, I told you so, and they change it again. And he said, when I see the students sitting, working like that, and they are discussing the subject, and they are forgetting everything around them, he says, this is a little bit like when you have bread in the oven. It's beginning to smell like engineering. And, you know, when you look at this list of what he wanted them to learn, you can't say if this is communication skills or if it is the technical subject, because they are actually really integrated. So you can't see where the communication skills end and the subject knowledge starts. They are really one and the same. And that goes for so many of the skills and abilities that we want the students to learn, like ethics, for instance. A lot of times ethics is taught as if it was a soft skill that had nothing to do with the technical content. I want ethics to be discussed in the technical courses where that is relevant. Sustainable development, I already showed you. Teamwork. A lot of people think about teamwork as a soft skill that is separate from the technical knowledge. It isn't. Yeah, it has everything to do with the technical knowledge and your ability to discuss the subject. So I really don't believe in separate courses where you learn the soft stuff. And I think instead it has to go within the technical courses taught by the technical faculty, sometimes with the help of experts on sustainable development or ethics or communication, whatever. But I think it has to go into the core of engineering education courses. And so we think about those skills as embedded and inseparable from the technical knowledge. And we never call them soft skills. I have a very heavy book to hit on the head of anybody who says soft skills, because they are not soft. If we call them soft skills, we show that they are on the periphery of the curriculum. We show that they are not worth it. I can tell you, they are really, really difficult for many of our students to learn. They are not soft. They are hard, and they are integrated with the technical content. Progression is, I think, a key concept for CDIO, because we work a lot with the progression throughout the curriculum. And I think we are also used in talking about progression when it comes to the subject content. It's obvious that courses are built on each other and you go deeper and deeper and further and further. But there are so many other dimensions of progression. And it's actually really interesting to have faculty discuss the program as a whole and discuss what kinds of progression they see through the program. Many faculty members would be interested, I think, in having a dialogue with their colleagues on how to help students progress intensely through the curriculum. Then, of course, And this is a warning from a person who has been working on curriculum development for 20 years. Sometimes it becomes very important for the faculty members and the program leaders to document this progression. So you make a matrix where you show which of the program level learning outcomes this course addresses. And this picture, it's an Excel spreadsheet, and when he printed it, it goes all the way down to the floor. And I think it's, and this one is actually how to decide on a syllabus, going through all the faculty organization. And I think I must warn you, if you look into CDIO, there are some people who look at it as an accountancy thing, or evaluation and documentation, and it's sometimes it becomes too focused on creating the perfect Excel spreadsheet, documenting exactly where everything is taught in the program, but too little focus on making this an enjoyable and stimulating development for faculty. Having faculty creativity and faculty joy of teaching be the important thing. And I think this rationalistic perfectionism actually kills a lot of joy with the faculty. It becomes more important what you have in that matrix document of the professor than what actually happens in the course. So it's just a warning not to fall into the trap of over documentation. And especially, you don't know him, but I know this guy. He happens to be the best teacher we have at KTH. If not the best, okay, one of the 3 best or something. He should not be doing a lot of boring Excel sheet overview of a program. He should be meeting the students and not doing bureaucratic administrative stuff. So try to keep the joy. Try not to start with, evaluations and documentation and burdening faculty. Try to appeal to their more creative side, making them want to do these things. Remember why we do it. So sorry, this is a long life of seeing things go wrong sometimes. So quickly about course development. We often you can say that the limiting factor is actually teacher time. A lot of faculty members say, oh, this all sounds wonderful, but I don't have time. I'm already working as hard as I can. And that is true. And in fact, we're never going to get more time. So whatever new curriculum we come up with, or whatever new course we come up with, we are probably never going to have 50% more time to teach it, or 50% more resources to teach it. That's just not realistic. We can wish for it, but it will not happen. So I have focused exclusively on thinking about what can we do if we just reassign the time. So we use the same teaching resources, but we use that time differently so that we get better student learning. And actually, this is a whole different workshop. I have a workshop like that. But standard 10 is about faculty teaching competence. So in CDIO, we have been focusing a lot on how can we help faculty develop their competence in teaching and their competence in course development and program development, so that we get much better learning out of the levels of resources that we already have. Congratulations to anyone who can double their resources, but in my experience, that I haven't seen that happen. Actually, I've seen a lot of people get extra resources to support the transformation, because sometimes the transformation needs an investment. But then the steady state teaching has to be sustainable on the normal funding level, because you won't get extra funding forever. But you can sometimes get extra money to support the transition or the transformation as an investment. So I think that's a very important rule. Never ever devise ways of working that you cannot sustain in the future on normal resources. If you only use the money or the extra resources for the transformation, you can get a lot done, but make sure that the steady state can support itself. Here are some of the courses, the faculty development courses in at my university. I don't know why I put it there. I'm going to put a few ideas together. I'll skip this one, of course. If you have this situation, the matrix discussion, you can say that this one symbolizes the faculty discussion, like which course should contribute to what competencies, to what skills, for instance. Which courses should contribute to sustainable development, or which courses should contribute to communication skills. And so Stefan, when he said, I'm prepared to address communication skills in my course, he was in a discussion like that. And that means he takes on some learning objectives that have to do with communication skills. But then after that discussion, he can actually go home to his corridor and discuss with his teaching team, how should those learning objectives be reflected in the course activities and in the assessment. Because you can do that in so many different ways. And I think it's actually a really, it really helps bring out the best in faculty. If you can have a negotiation with them what their course should achieve, what kind of learning their courses should achieve. But they should decide how it's reflected in the teaching and learning, how it's reflected in the assessment. And that is the sort of, you can call it a solution-independent approach, that you allow faculty the liberty and the independence to design their own teaching, because we all have preferences. We all have different contexts depending on the subject. So because it can be implemented in 1,000 different ways, I think faculty should have a lot of freedom. So I would never go out and say, now everyone has to do it exactly like this. But you should be able to have faculty accept responsibility to address the learning outcomes that are necessary for the program. Okay, here we have standard 7. It's really the same thing as standard. Standard 3 was integrated curriculum. Standard 7 is integrated learning experiences. So it's the same, but on the course level. So if the curriculum is integrated in that it has both disciplinary knowledge and the skills or approaches, this is the same on the course level. So you have learning objectives that have to do with the disciplinary knowledge and some to do with the engineering skills or other competencies. Standard 8 recommends active learning and experiential learning. So PBL would definitely fit under that, but you can have many other forms of active learning as well. And standard 11 really says that you should assess, you have to assess both the disciplinary knowledge and the skills. If you only assess one of them, students will quickly realize and they will not focus on the other one. So in my opinion, they need to be integrated also in assessment. So here are the 12 standards again. Some have to do with the curriculum development, some are on course level, and some have to do with faculty. So these are, I call them aligned strategies. They are, in a way, they are there to show like the whole comprehensive approach of CDIO. So we're not just doing one thing, we are taking on the curriculum as a whole. So if you see the standards, please think of them as not as something written by an evaluation agency, but actually they are live and interesting strategies for developing a curriculum. And PBL is one of the important components, of course. So that was CDIO, the idea, the methodology, and the community. And I also put in a slide with some reading recommendations. Now, I'm so sorry that you are recording me because I'm going to say don't read the book. It's a bit too long. I think you would get a more concise introduction if you read a few papers. And I can give you some PDF versions so that you can download some supporting documentation after this. There are some new developments in CDIO, which will be presented on Monday, Tuesday, Wednesday. We are updating the CDIO syllabus to 3.0. We are deciding on which optional standards to develop. We already have 4 optional standards decided last year. So we will see some experiences from that, and maybe we will decide to develop some more optional standards. So those are the things I'm going to be discussing next week with a couple of 100 other people. If you're interested in participating in CDIO, the CDIO meetings are open for all. I think it's too late to register for the Bangkok conference on Monday. So you have Iceland next year if you want, but also you have the Asian regional meeting. We also have regions in the world. I think we have 5 regions or so. And the Asian regional meeting this fall is organized online, and it's October 26 to 28. So that could be interesting for you. It will even be in your time zone. And if you go to cdio.org, you can find that meeting when it's advertised. And it's also possible for your university to become a CDIO collaborator after you have gotten to know CDIO a little bit more. Maybe you have been to a first meeting to check it out. Maybe you have read a little. If you want to, and if you can convince your dean or your president, you can join CDIO as a collaborator. And there is no membership fee involved. So everything is just, everyone just funds their own work, so to speak. So I will try to change the, let's see, how are we doing for time? Do we have time for considering questions in group?
Yeah, we can. We have the session till 7:30 p.m. So it's just 7 right now.
That's perfect, actually. So if you take again the Menti link, I will quickly run to the other computer to change the slide, and you can enter questions there.
Yeah.
So take 10 minutes to discuss in groups and submit questions on the Menti or in the chat, and I will try to answer as many as we have time for.
Yes, they are coming back.
Thank you for staying so long. I know it's getting late in India, so thank you so much for coming back here. So I have seen some of the questions that you submitted on Mentimeter. Some of them were about the comparison between CDIO and PBL. So one question was, is it fair to compare CDIO and PBL? And I have to say, they are two very different things. But the reason why Annette Kolmos and I wanted to write that paper to compare them was that we got so many questions. What's the difference? Or rather, many universities actually asked, both Annette and me, they said, should we do CDIO or should we do PBL? And we said, we have to write a paper to explain what those two are. What are the similarities? I mean, there is an overlap in that PBL is part of CDIO, but there is also they are very complementary in that even if you do PBL, you might use CDIO for some of the curriculum approaches, and also maybe for discussing what can be done in the courses that you don't change into PBL, but you keep them in a subject course format. So you can absolutely use both. And we were so puzzled by the question, should we do this one or that one? So that's why we wrote that paper. So in a way I could say it's not really fair to compare them or to think that you have to do either PBL or CDIO. I think it's very good to have both in your toolbox, actually. Then I saw a question. Someone said it's very difficult for us to do PBL because we have large classes, like 60 students. And this is actually one of the reasons why we have been working a lot on making those project courses, the design implement courses, sustainable to teach. I mean, my friends, the faculty members who teach some of those courses that I'm thinking of, they don't get more time in their schedule for teaching them than if they had been normal lecture courses. I mean, maybe they have more credits, so they get more, but per credit, they don't get more time. And therefore, we had to develop very cost-effective ways of teaching. And when we did that, we made sure that we used strategies to increase the quality of student learning while the teacher didn't work more than necessary, if you see what I mean. I have actually seen project courses where teachers are working totally unreasonable ways. It's almost like they think they have to live with the students in the lab to work together with them. And I think they do it because that is fun, but it's not sustainable really from a workload perspective. So, and I mean, it's fine if you want to do it, but it's one of the reasons why there is resistance to PBL, because people think it is so much more expensive. So we really wanted to show ways to work with in a project-based approach that was not unreasonably expensive. But that is a separate workshop, actually. You can come to a CDIO conference and we can continue on that. Then there was another question, and I thought that was such a good, interesting perspective. Someone asked about lifelong learning. Our aim is that the students should be able to go on learning after graduation. So how can we reflect that in our learning outcomes, learning objectives? Now, that is such an important thing to consider. I try to inspire faculty to think about the course as a model for how the students can learn in the future. And that means we should not have the students be accustomed to only learning when a teacher is present, but we should help them practice or acquire habits of learning that are actually centered on themselves and others. So for instance, when we have students do peer feedback on each other's work, one of the reasons is that actually we have it in our program learning outcomes. You should be able to evaluate the quality of your own work and the work of others. So we have course design where they give each other feedback and they evaluate the quality of their own work and the work of others. And that is, developing that judgment is a very important life skill for them if they are to learn anything in the future, because they can't rely on always having a teacher nearby who can tell them, yes, that was the right answer, you can sit down. So if we stay in that mode where students are depending on the teacher for knowing what is the right answer, knowing what is the good quality solution, for instance, then we are setting them up for not being able to learn further on their own. So we need to help them develop their own judgment and their own habits for learning things. There is a really interesting literature coming from Australia right now in the past few years by David Bowd and someone called Carles, I think. Is it David Carles as well? They are writing about feedback and they're writing about the development of judgment in professional education. And it's really, really interesting stuff. And I think that's a perspective that is so important for us all to consider in education. So those were the questions that I took from the Menti 10 minutes ago. So evaluation system in CDIO. I'm not sure what you mean with the question, but I can. It reminds me that I should explain. So the CDIO standards, we have also developed rubrics for self-evaluation. So for a given engineering program, you can actually evaluate which level, to what extent it fulfills the CDIO standard. And that is only to, we are only offering it as self-evaluation. So if you want, you can evaluate your own program using the CDIO standards and the rubrics that we have developed for it. But CDIO is not an accreditation agency. We don't want to go into that business. We are, you could say, we are a community of very happy faculty members who love to develop courses and programs and who love to share our experiences. We are not the bad guys. We are not the control institute or we are not the accountants. So but we offer those documents as a structure for self-evaluation. And it's actually quite fun to do a self-evaluation of your program and then consider, which improvements do we want to make? And then you make a new self-evaluation. You can see that you have increased from 3 to 4 in some standards, but it's more offered as a voluntary thing, and we don't want to focus on the control aspect or the I don't know the English word for it, the evaluation aspect. I mean, evaluation is a great tool, and being able to measure your progress is great also. But I think what really brings out the best in faculty is not to control them or audit them, it's to inspire them. So at least if you ask me, you might find a CDIO person who is more into evaluation and control and Excel spreadsheets than I am. I'm in the business of inspiration. I think if I look back in 20 years, the 20 years that I've been doing this, some of the best results have come from starting with a group of faculty and doing something that they enjoyed. And then they can then go on and do many more things, and they can help other colleagues do those things. So I like to work with a positive approach. I think it's the only sustainable way of doing things. Okay, so we see now a few questions. So one question was, can you join CDIO as an individual? Well, you can attend CDIO activities. You can come to the conference, you can come to the regional meeting, you can participate in everything. But the collaborator status is to institutions, or actually programs. So if you have a program, the program can join, or the faculty that owns the program. So the last question that came, can we access CDIO workshops? Yes, you can. When we offer CDIO workshops in conjunction with the CDIO conference, for instance, then anyone can join the conference and join the workshops. And it's not unusual that we get invitations to come to a university to give a workshop to like 100 faculty members at the same time. That is quite fun. Oh, there are such good questions here. So the question, is CDIO more suitable for technology-oriented courses? So CDIO was created by engineering educators, and we were thinking about engineers and engineering educational programs. But I actually think it would be very easy to transform the whole concept to any professional education. And we have seen such contributions in the conference, for instance, where people have used CDIO as a concept for improving business education or teacher education, or I'm not sure if I've seen any medical education, but it should be possible. So, but it starts with a vision of the graduate. So I think if you can have a vision of what the graduate should be able to do, then you can actually use the CDIO framework to design an education for that. If you don't have a vision of what the graduates should do, like history, for instance, they don't like to say that you're a history professional, and so it's harder for them because you can do many different things when you learn history. So if you just have a subject focus, then but if it's professional education, no problem at all. I think we're running out of time. Is it bedtime for you? Almost.
Hello.
Here it's 4 o'clock in the afternoon.
Hello.
Keith is there? Vijayalakshmi.
Hello.
Yeah.
Yes, sir. Yes, sir.
Yeah. You are the session, workshop in charge?
Yes, sir. Yes, sir.
Okay.
Ma'am, we can take one more question.
Madam, time agide, madam.
Okay.
Bala time agide.
It's okay.
Nare bedage matte barbeku.
Okay.
The final comment here is actually very insightful, that you need more awareness on CDIO and training programs. And I think it has been one of the key components of a successful educational development is to work on the faculty development. to first of all, to give faculty the competence for doing something differently. If you only have your existing level of understanding, the only thing you can do is more of the same. So if you want people to be able to do things a little bit differently, you need to support them. You can't just require them to do differently. You have to have a balance between the requirements or the demands and the support that you provide them. So I think those should be in a balance, and creating the support and the faculty development activities, I think, is a key thing. First of all, to make everyone aware and also prevent or handle some of the resistance that you might have. You have to take away the ammunition from the people who are resisting because they understand. They are not so afraid anymore when they understand what is involved. And then you have to support them in the transition and not make unreasonable requirements. That's what I would say. Balance between demands and support, and the focus on supporting and helping faculty members in achieving the transition. That's an important strategy.
Thank you, madam. Thank you very much. So this was a wonderful workshop session. And on behalf of RRSPBL 2021 organizing committee, I would like to thank madam and all the participants for gracing this occasion and making this a success. And then I just want to announce tomorrow's session. It will start at 9:30. The first keynote at 9:30. Please join 10 minutes early. Thank you very much. Thank you, one and all.